review before we talk about the digestive system, you know, because I don't like you to forget about the other systems of the body, right? There is one of the first systems we studied is actually the largest organ of your body, and it's the one that we touch all day long, and we use to touch all day long. Miss Nguyen, what is that system called that's made up of my hair, skin, and nails?
I don't know. Kanan, but I don't know what about that.
The system that's made up of my hair, skin, and nails. What's that system called? It starts with I. In.
System. I don't know how to talk about that. And I think about Kanan is the system. I don't know how to solve that.
Okay, let's make sure that we're talking about the same thing and then how we're saying it and stuff. So the hair, skin, and nails composes your integumentary system.
Yeah.
Which is a big word. Can you say in?
In.
Teg.
Teg.
You.
You.
Men.
Man.
Terry.
Terry.
Integumentary.
In.
It's hard. Tag.
In time.
You.
You.
Men.
Man.
Terry.
Terry.
In. Tag you.
In time you man Terry.
That was great. Bam. You're done. Cool. Kick back. Integumentary system. That's right. Miss Stanley, what makes up the integumentary system?
Did you say Stanley?
I did.
Okay, so the hair, skin, and nails.
Cool. Thank you very much. And Miss Harper, what does the integumentary system do for me?
The integumentary system can protect you, your skin, and skin barrier. It can also produce vitamin D.
Yeah.
It's also like a thermal regulation.
Yeah, I love that. Heat regulation.
Skin sensors, like sensory.
Yeah, sense of touch, sense of pressure, heat, cold, all sorts of stuff, yeah.
Yes.
Well said. Thank you. Who wants a thinking question? It's a thinking question. It's not really a, did you remember something?
Me.
Oh, me. Now, okay. So Miss Monreal, I said a long time ago, I've said it many times, that all the systems of the body are divided up for us to learn about them. But they really could be combined, right? They're divided up for our understanding, but that's like sawing somebody's arm off and trying to understand just the arm, like the arm's connected to the body and all this kind of stuff. So are there other systems that the integumentary system could combine with that it is part of, or they are part of it, or they overlap?
Well, I mean, you have blood and you have veins and.
So what system is that?
Capillary, the circulatory system.
Okay, so what you're telling me is the integumentary system would not be alive if it didn't get blood flow. So it has to be combined with the circulatory system for sure. Absolutely. I love that. Anything else?
Well, what is that? Nervous system.
Nervous system, and how is it combined with the nervous system?
Well, with the nerves, because you would need that, right? For like glands, I don't know.
Well, now you're hopping around a little bit. You're on the right track, by the way. Glands is part of a different system.
But,
Okay, well, gland is, we just did it. Endocrine system. Okay,
Endocrine.
but the nerves, I don't know, man.
Okay, take a break, just pay attention to driving, we'll get back to you. Miss Petrie, were you gonna say something?
yeah, I was gonna say skeletal system because the bones have blood as well, right?
Sure they do, but that's tying them to the circulatory system. We're talking about the integumentary system. You're absolutely right, by the way, about the blood and all that stuff. So
So
how,
the head, skin, and nails, and how that ties in with another system. Is that
yeah,
what you're
and Miss
saying?
Monreal made a great point that it has to tie into the circulatory system because it wouldn't exist without the circulatory system. She's 100% right. Then she started to talk about nerves and glands and stuff, and then I kind of lost her at that point.
Okay,
no,
so
if someone else doesn't have the answer.
Yeah, hold on, Miss Monreal.
Okay.
So were you going to say something, Miss Petrie? No? Anybody else?
but isn't that the incident that the circulatory system is what it's connected with?
Definitely connected to the circulatory system, sure. Absolutely.
Oh, so there's other, so now we're trying to take the circulatory system and see what that attaches to?
No,
What system
still
that goes to
integumentary
that?
system. I'm trying, I'm not doing a very good job actually as a teacher, but I'm trying to remind you that these systems were invented by some guy like me sitting around going, well, we need to understand how the body works, so let's just talk about the blood. We'll call that the circulatory system, but you can't really separate it from the other stuff. So your integumentary system is your hair, skin, and nails, but it's intimately related to other systems of your body. One is your circulatory system because it needs it to stay alive. Absolutely. And Mr. Sorry. You said something, Mr. Kondaris? I didn't hear you though.
I was just saying, like, integumentary is nervous, like touch sensory.
Oh, okay. That's a much more clear explanation. So what he is saying is the nervous system, remember the thing that my central nervous system, my brain and my spine, it goes out and at the end of the nerves, where are most of those ends of the nerves? In my integumentary system. Not all of them, but many of them. And those are the things that have the sensors on them. So my nervous system sensors, the ends of all my nerves, not all of them, a vast majority of them, are in my integumentary system. Absolutely. So when you rip off a piece of skin, it's got some nervous system in there and some circulatory system in there. Cool. Awesome. I love it. Anything else that I'm missing? I'm just trying to tie stuff back together. Yeah?
It'll take a while, yes. But I don't know which gland it would be, but I bet if something wasn't working right in one of your glands, you could have ugly looking skin.
Actually, you're right. So skin is a really good indicator of all sorts of health things. Absolutely. And hormonal indifferences create problems in your integumentary system. Which is why when people are going through puberty, they get lots of pimples, right? Not always, but they can. That's a hormonal imbalance, right? A lot of hormones are coming on really strong, and there's some imbalances there, and that's a hormonal imbalance, and that is due to the endocrine system affecting the integumentary system. I like it. Cool. Okay. So let me get us back on track because I think maybe that was just too far out there. Miss Hanson, what is the integumentary system?
Hair, skin, and nails.
Cool. What does it do for me?
What?
What does it do for us? Why do we have it?
They help regulate body temperature, create vitamin D access barrier, and they have all our sensory organs.
Cool. I like it. How does it act as a heat regulator?
Well, it helps us produce sweat.
Oh, and what does sweat do for me?
It cools us off.
Yes. And how does it cool me off?
By sweating. I don't know.
That's okay. I didn't make it very clear. I'm sorry, I was just getting down that kind of rudimentary level. Everybody, sweat cools you off like an evaporative cooler cools your house off. When the sweat evaporates in the air, it carries heat away with it. That's literally what it does. So it's not really the sweat, it's the water when it evaporates goes away and cools you down. And I didn't make that very clear, Ms. Hanson. I was just kind of digging down. Thank you. Thank you very much. Miss Yanas, if I pull off the layer of skin underneath it, I will see muscle, and muscle is part of what system?
The muscular system?
Yes! And what 3 kinds of muscle are there?
Cardiac, smooth, and skeletal.
Cool. In what system do I find cardiac muscle?
The heart.
Yeah. This is not fair because I've never asked this question before. In what system would I find smooth muscle besides the muscular system?
Isn't that the lining of like your organs and veins?
Yeah, so you could probably argue you can find it in lots of systems. One is the circulatory system, because arteries and veins. Another one is the system we're going to study today. The digestive system has smooth muscle all around it, all the way down, start to finish. Good. Cool. Thank you. Miss Balatic? Miss Balatic, what 3 types of muscle are there?
Smooth, cardiac, and skeletal.
Thank you. And where do I find skeletal muscle? What does skeletal muscle do?
It's muscle that is attached to bones.
Mm-hmm. Yeah. And what does it do?
Contract.
Yeah, actually I love that answer. It contracts to help me move, but you're right. It only does one thing, contracts to help me move. Do you know what type of fascia connects muscle to bone?
What type?
Yeah, I've never asked the question in this way, which is why I'm worried it's going to be confusing. I think you know the answer, but I've never asked it in this way. So when muscle attaches to bone, it attaches via something. It doesn't just hook straight to the bone. It attaches by this thing, this fascia that attaches muscle to bone. Do you know what that fascia is called? It starts with a T.
It starts with a T.
T. Yeah. But I apologize, by the way. It's a tough question because I haven't asked it in this way.
Yeah, I'm not quite sure.
Okay. Do you remember what attaches muscle to bone? If I just say it like that, muscle to bone.
The skeletal muscle?
You're right, skeletal
Or
muscle
that
does.
attaches the...
You're right, by the way. Skeletal muscle attaches to bone. You're absolutely right.
Yeah.
But there's a thing. Ligaments attach bone to bone. What attaches muscle to bone? Ligaments. I'm so sorry. What'd you say?
Tendons?
Yes! Tendon is the fascia that attaches muscle to bone. Fantastic. I knew you knew. It's just the way I asked the question was very difficult. Thank you very much, Ms. Blodek. That was fantastic. Mr. Kandaris, do you remember the contractile units that are found in muscle?
They called sarcomeres.
They are, all day long, sir. Thank you very much. And then inside them they have thick and thin what?
Filaments.
Yes. And do you remember what they're made with? What 2 proteins?
Muscle fibers.
The muscle fiber is the whole muscle made up of a whole bunch of sarcomeres. Inside there, the thick and thin filaments are made with 2 different types of protein. One starts with an A and one starts with an M.
I don't remember that one.
Actin and myosin. Actin and myosin, I wouldn't, by the way, it's not going to change your life to know it either, but I'm just kind of reviewing here. Actin and myosin. Thank you, sir. Miss Cooper. Miss Cooper, are you there? Yes, you are. Miss Cooper, unmute your mic so you can answer this question that's coming at you right now. Miss Cooper,
Well, I was gonna wait for you to ask.
I want you ready. I want you ready to fire. when a muscle fires, when a muscle contracts, when a muscle fiber contracts, a single fiber, which is a long muscle cell, with a whole bunch of sarcomeres in it, a whole bunch of thin and thick filaments in it, a whole bunch of actin and myosin in it, when it contracts, can it choose how much to contract? Can it contract like 10% of power or 93% of power or can, can it throttle itself?
No.
No. What can it do?
Pretty sure it's all or nothing, right?
All or none is exactly the answer. Thank you. And all or nothing is close enough for me. It works on an all or none principle. Yeah. Yes. Cool. Hey, what system, Miss Cooper, attaches to the muscular system to tell it to contract? Because it doesn't just do it on its own, I hope. Otherwise, I'd do silly stuff like this without being in control. But I am in control. And so what system tells my muscles to contract? Just the system. I think it's the system.
What, your nervous system?
Darn straight, my nervous system, absolutely. And when a nerve fiber, which is a nerve wire really, but when a nerve fiber sends a signal to either one or multiple fibers of muscle, because sometimes they're attached to just one, sometimes they're attached to 10 or 100, it doesn't matter. But when it sends a signal, can a nerve fiber kind of throttle its stuff a little bit? Can it just send a light signal sometimes or stronger signal other times?
Yes.
How about we think about the muscle for a second here? Remember the muscle worked on the all or none principle? It's just on or off?
Oh, well then that would work on the all or none principle too.
It does, yes. So basically the nerve says fire or don't fire and the muscle says yes or no. All or none. So, last question, Ms. Cooper. If I want my body then to produce more strength, like if I'm not lifting this pen but all of a sudden I'm lifting a rock, how do I make this movement stronger?
What?
I know.
I'm sorry, say it again.
Well, we decided that I work on an all or none principle. And we decided that when I lift this pen, let's say a couple of nerves send some signals to a couple of muscle fibers and say go. The nerves say all, they're just light switches, they flip on. The muscle goes, heck yeah, they try as hard as they can, and those muscle fibers pull as hard as they can and I lift this pen. What happens if I need to lift something heavier?
Well, I don't know, because it works on all or none.
Right, it does. Yeah.
So how could you make it stronger? I don't understand.
I love the way you asked that question, thank you. Let me explain. But I love the way you asked it because it's exactly where I want us thinking to go. A muscle fiber is what, everybody? It's one cell. How many muscle fibers are probably in my biceps brachii? I don't know the answer to this question, but
I don't know.
3? Does that sound like a good number? These things are smaller than a human hair. Smaller than a human hair. My biceps are about that big around. I don't know. I wish it was this big around, but I don't think so. I think it's more like that. So how many items can I put that are much, much smaller than a human hair in there? How big a ponytail can I get in there? 4?
Sounds good.
You think 4 human hairs would kind of fill up that area pretty good? Ponytail made with 4 human hairs? You're feeling good about that answer?
Wouldn't it be like thousands?
Yeah, might even be like millions.
Yeah.
Yeah, I don't know the answer, but I guarantee you it's over 1 million. It takes 1 million muscle fibers, and my body can all or nothing 1 of them, 2 of them, 10 of them, 100 of them, 100,000 of them, 1.1 million of them, and that's how it controls power. Right? Each muscle fiber is actually pretty impressively strong, but one could barely move a paper clip, right? So what your body does is when it needs to lift something heavier, it recruits more fibers. It's all or nothing, right? But instead of all or nothing for the 10 fibers to lift this pen, it gives all or nothing for 1,000 if it's a rock. Or if it's you, I have to lift you up. It's 100,000 fibers. They're all or nothing, but it just recruits more fibers. So when I'm lifting this pen, my entire bicep is not working. 10 of those little hair-like fibers are working right now. That's it. Now,
Well, if you have
A lot more.
what?
Whereas like this takes a lot more.
Yes, you recruit more muscle fibers. Yes, Miss Petrie, what were you going to say?
I was gonna ask, how would you explain in some simple terms how all or nothing works?
It's all right, I don't know if this helps, but here's how I imagine.
Note-taking terms, how
Yeah.
would you explain?
Okay. Two different ways. Here's my super simple analogy, but the only problem is I don't love this analogy because it doesn't expand up very well. But let's imagine this.
Okay.
I've got a big cart here. I've got a big cart here. It's empty right now. I've got a whole bucket of trained mice. Whole bucket of trained mice over in the corner of the classroom. And I've trained these mice for years, and they're amazing. And if I give them a little shock or a little prick, they will run as hard as they can, as fast as they can, for as long as they can. So when this cart is empty, by the way though, they're just mice, so they're not too smart. So I was not able to actually train them to kind of just jog sometimes. Man, they either just lay around and sleep and eat and have mice daydreams, or when I prick them or shock them a little bit, they run as hard as they can for as fast as they can for as long as they can. They're these kind of all or nothing kind of mice, right? They don't understand strolling. They don't stroll anywhere. They either run as hard as they can, as fast as they can, for as long as they can, or they do nothing. And so when I want to move this cart and it's empty, I just hook up one cute adorable, oh geez, adorable little mouse to this thing. That's my adorable little mouse. And I go ahead and I give him a little shock actually. I've got this little wire system. Give him a little shock and he just runs as hard as he can and the cart kind of moves along. It's perfect. Now, if I want the cart to move faster, or if I've loaded it up with a whole bunch of rocks, he'll keep trying, but it doesn't go anywhere. He's just scurrying along there, but it just doesn't go anywhere. So what do? I literally put more mice on there. More mice on there. More mice on there. Right? And by the way, as it's moving along now, when I want it to slow down, I can't tell the mice to slow down. I actually have to kind of shut them off. So, because the mice, they're either all or nothing. So when I want more power, I've got to get more mice on board. Now, muscles are a lot like this too. This is a muscle cell. 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 Together they make a muscle. Now I don't have time to draw a million of those, but there probably is a million cells in a typical muscle. There might be 10 million, honestly, in your thigh or something. But they're like my mice. And so when I want to lift up a pen, my nervous system sends a signal down and goes, kick this one off. The rest of these guys are just lazy. They just lay there. And that one goes, ah! He's really working. But it's just one mouse. So he picks up the pen. When I want to pick up a rock, my nervous system says, fire all these off. Or whatever you need to lift the rock, right? And it fires them all off. Does that help?
Yes.
And that's all or none. And so these muscles, these mice run all or none, and the nervous system sends all or none. My light switch in this
Okay,
class.
so the muscular system and the nervous system are the systems that work together.
Oh, for sure. For sure. Yeah. The muscular system, in general, your cardiac muscle is a little bit different, but in general, it doesn't do anything about the nervous system telling it to do something. Some of that's unconscious. We've talked about this in the nervous system. Some of that's unconscious, and some of that's conscious. But yes, what happens is muscle fiber is excitable, and when you send it an electric shock, it's really a chemical signal at the end. But anyway, you give it a chemical signal, it does the one thing that muscle fiber can do, which is contract. Yeah. And so your brain knows how many fibers to fire to get you a certain amount of power. Yeah. Cool. I love it. Okay. So, Miss Hunter. Are you there, Miss Hunter?
Yes, I'm here.
Oh, cool. I mean, I figured you were. I really should have said, can you hear me? Because I know it sometimes doesn't come through. So, Miss Hunter, we just talked about a lot of stuff. Let's review for everybody. What's the first system we learned about that I'm touching right now? What system am I touching right now?
The integumentary system.
Yes. See, Miss Nguyen, it's not easy. Integumentary system, yes. And what is it composed of? What is it comprised of?
Hair, skin, and nails.
Thank you, ma'am. And what does it do for me?
It regulates temperature. It absorbs vitamin D. It
Creates vitamin D, but yes.
Oh yeah. Oh my god. That's my thing. Temperature, vitamin D. Oh, it's a barrier against like the world.
Yes, definitely.
What was that?
Definitely. Barrier, definitely.
Oh, it's sensory. Yes.
Cool. I love it. That's good. That's good enough. There are 3 main layers of skin. Do you remember what they're called?
Yeah. Dermis.
What?
Oh no, that's not the first one. Epidermis.
Yep.
Dermis. And then, hypodermis, yes.
Yeah, I was just being lazy. Epidermis, dermis, hypodermis. Yes. Awesome. And what are the other 2 names for hypodermis?
Subcutaneous.
Yes, ma'am.
And
Sub-Q.
go ahead.
Go ahead.
Superficial fascia.
I love that. Okay. And then, Miss Hunter, we peeled off the skin and we went down to the muscular system. And there were 3 types of muscles. What were they?
Cardiac, smooth, and oh my god, I was going to say skeletal muscle.
Yeah, you
That's
should.
not a thing. Oh, that is a thing?
Yeah.
That sounds weird.
Skeletal muscles are the ones that we study most of the time. So, cool. Skeletal muscles attached to bone via what kind of fascia? What hooks muscle to bone?
Tendon?
Yeah, tendons. Hook muscle to bone. Cool. And then we decided that this muscle in some ways had layers of fascia around it. And we haven't talked about this today, but we've talked about it a lot. And what's the top layer of fascia that goes around multiple muscles?
Oh my god. Oh, epimysium.
Thank you. And then there's
Paramysium.
Yep, and then there's
Endo.
yes, ma'am.
Yeah.
Oh my gosh, that's awesome. Of course, all this muscle attaches to all this muscle, not all of it, but the muscle that we're concerned about attaches to another system of the body. It attaches to your bones, and your bones are part of what system?
The skeletal system.
Yeah, skeletal system is essentially your bones and related joints and fascia. Hey, what attaches bone to bone? What fascia attaches bone to bone?
Ligaments.
Yeah! Awesome. Hey, what's the fascia that's around bone?
Osteo something.
Oh, no. Oh, periosteum. I knew it was
That's beautiful.
osteo something.
That's beautiful. That's beautiful. Cool. That's awesome. Okay, ma'am, I think that's enough. Thank you.
Thank you.
Thank you. Miss Felix Osuna.
Yes.
Miss Felix Osuna, what does the skeletal system do for me?
It is mineral storage, movement, support, protection, and also has blood cell production.
Yeah, red and white blood cell production, which would make it pretty important to the cardiovascular system because you can't move blood around if you don't have any. That's pretty awesome. Okay. Thank you. Thank you. Awesome. And Miss Torres, you said to be nice to you today, so I wasn't calling on you. I was going to give you a pass. Do you want me to not call on you or call on you? I really mean that.
No, I'm okay.
Okay. You're very engaged all the time, and when you're a very engaged student, I'm totally happy to give you a pass. So, but
I'm okay.
good, because it would not be a good day for me if I couldn't call on you. So thank you. So Ms. Torres, we've been talking about the integumentary system, which is your hair, skin, and nails. And we even talked about how the nervous system has nerve endings in your hair, skin, and nails, which is, well, in your skin, sorry, which is how you sense heat, cold, pressure, all sorts of stuff. So the nervous system kind of ends in your skin in some ways. We talked about the muscular system, which, by the way, the nervous system works on all or nothing to tell the muscles to fire in the skeletal muscles. And the nervous system also goes to smooth and cardiac muscle too. But so that's kind of cool. So the nervous system hooks in there too. And nervous system, by the way, hooks into your bones too. And so let's talk about the nervous system. Yeah?
Yes.
What are the two big physical sections of the nervous system?
It was nerves.
Yeah, but don't go there yet.
Oh.
What is the two big sections? We have kind of one down the middle and one off to the side.
Central nervous.
Yeah, what makes up the central nervous system?
The brain and the spinal cord.
Yeah! And then what's all the stuff off to the side?
Nerves.
Yes, but what kind of nerves?
Okay.
What do we call them?
Peripheral.
Peripheral, thank you. And those go everywhere. Awesome. Awesome, awesome, awesome. And then we said that this nervous system, all of it, some of it operates with me knowing, and I'm choosing what for it to do, and some of it operates kind of automatically. What do we call those two sections?
Automatic and somatic.
Yeah, somatic and autonomic, but you're right. So somatic is
Somatic.
under my control,
Voluntary.
and autonomic is automatic. Cool. And then we said the autonomic kind of operated in two automatic modes. One was kind of rest and digest, the other one was fight or flight. What are those two modes?
Sympathetic, and parasympathetic. Or
Yep. Which one is the rest and digest?
Parasympathetic.
You nailed it.
And sympathetic is the fight or fight.
That was beautiful. Awesome. Thank you, ma'am.
Thank you.
Miss Monreal. Are you in the car wash tunnel right now? Miss Monreal. Talk to me. Dígame. There you are.
Can you hear me?
Now I can hear you, yeah.
Okay.
All right. Nervous system. Let's break down the nervous system. It's divided into two major parts. What are those? Physical parts. And now we can't hear you. You have frozen. This is so sad. Yeah. All right, I'm coming back to you later, Miss Monreal, because you're frozen. I can't hear you. Miss Stanley. Miss Stanley, tell me the two major physical parts of the nervous system.
The major parts of the nervous system.
Physical parts, yeah.
Wouldn't that be like the spinal cord and the brain?
Yep, what part is that? Brain and spinal cord is what? What's it called? What?
Then, is it nervous?
This part that's in the center of my body, brain and spinal cord, what do we call it?
I don't know why, but I'm drawing a blank right now.
Central. This is your central nervous system.
Central nervous system.
And then what's off to the sides? What's off to the sides?
The peripheral.
Peripheral. Awesome. And then these two systems can work with my knowing or not knowing. And what are those two modes called?
Two bones?
What now?
What did you ask?
I'm asking that this system, the central and peripheral nervous system, can operate without me knowing, kind of automatically, or with my knowledge.
Autonomic and the
Somatic.
I say that. Somatic. I wanted to call it somatic.
Which one is under my control?
The somatic.
Yeah, excellent. And the autonomic, because it's automatic, has two automatic modes. What are those two modes?
Sympathetic and parasympathetic.
Yeah. Yep. Thank you. And which one of those do I want my clients to be in?
The parasympathetic.
Yeah, rest and digest. That's awesome. Cool. All right. And kind of, in a way, kind of unrelated to this discussion, you divided up all these nice stuff. These peripheral nerves, some are used to send signals out to tell my muscles to create effort, and some bring signals back in after I've had a sensory experience. After I've touched this finger, it sends a message up to my brain. Do you know what we call the two different?
Efferent and afferent.
Efferent and afferent. Thank you. Efferent are the ones sending motor nerves signals out to tell me to create effort. Afferent are coming back in. That's fantastic. Cool. Thank you, ma'am. Let's see. Miss Harper, can you tell me, last but not least, and then we'll get on to the digestive system. I think we spent enough time on this, but there is fascia. There's fascia around nerves too. Do you remember what it's called, the three layers of fascia around the nerves? First you have around the big bundles, then smaller bundles, then the individual nerve fibers.
The epineuron.
Yep.
And then the second one is the perineuron.
Yeah.
And the last one is the endomeuron.
Thank you. Okay. That was beautiful, everybody. Okay. And I forgot about the endocrine system. So just really quickly, Miss Nguyen. Miss Nguyen, hi. What makes up the endocrine system? Like, what's in it? It's just really two things I'm looking for here. What makes up the endocrine system? Endocrine system.
I don't know how to call that.
Yeah, but I think you're getting ahead of yourself. Just what makes up the endocrine system? It's something that produces something. Something that produces something that happens to be chemical messengers.
You mean in the
glands produce? Yeah. Hormones. Hormones. And what are hormones? Like, what do they do? Like, what is a hormone?
Hormone, I'm sorry.
It's okay. It's okay. These are hard questions and they're in another language. It's fine. So they're chemical messengers. They're chemicals that talk to the rest of your body, the cells in your body. Cool?
Yeah.
All right. Don't worry. Thank you, ma'am. Miss Petrie, what's the endocrine system?
Glands and hormones?
Yeah. Glands produce hormones. What are hormones?
Sorry, I was taking notes.
It's okay. You're like, I was trying to write stuff down to learn it, and now I don't know it.
I know, it's not thrown off, I apologize.
No, don't feel that way at all.
Hormones
I was watching your
are-
work. Yeah.
Are those things that guys complain about all the time?
Yes. So why do we complain about them? What are they doing?
I'm looking.
Well, don't look for a second. Think about it.
Okay.
What do they do? They're chemicals, but they're chemicals that relay something, or they're chemicals that do something. And you don't even have to think big fancy things. They go around to your cells and they do something.
Do something?
Kind of. They're chemical messengers. They just go and talk to your cells and tell them to do stuff. So the answer you would have found in your book is chemical messenger. But I'm trying to put that in a simpler term. They really are a chemical message to tell your cells to do certain things. Right?
Okay.
Right? They might be like when we were using the joke about guys, it might be telling you to ovulate, and then we say you're being hormonal. Right?
Right.
And it is hormones telling you to ovulate. But it's also hormones telling you to lower your salt balance and, you know,
Right.
regulate all sorts of stuff. When you stop growing, when you go to sleep, all sorts of stuff. So they're messengers. So they're chemical messengers. Cool.
Okay.
Yeah, you're fine. We're good. Thank you for taking notes.
Okay.
I'm serious. I watched you doing work over there. It was good. It's good. Doesn't have to be perfect. Cool. Miss Yanez. So, what's the endocrine system?
Your glands and hormones.
Yeah. So, what do glands produce?
They produce the hormones.
Yes. And what are hormones?
They're chemical messengers
Yeah.
that tell your cells what to do.
Yeah. Beautiful statement, by the way. They are chemical messengers that tell your cells what to do, and your entire body is composed of cells. There's nothing in your body that's not a cell. Nothing. They talk to everybody. Hey, you find these glands everywhere, but really, where are some of the most powerful glands of the entire endocrine system found? Just roughly where? I don't mean you don't have to be real fancy. Roughly where would I find some of the most, they're not even the biggest, they're just some of the most powerful glands in your body. They tell you when to grow, when to stop growing. They do like 37 things, you know?
Is that like the hypothalamus and stuff
Yes. So I just was looking for head. They're found in your brain. Yeah.
like that? Okay.
Yeah, in the center of your brain. And that's your hypothalamus, your pituitary gland, all that stuff. But yeah, just found in that area. Cool. Thank you. Thank you. In your brain. In your brain. We have another very important one up here in our throat, but I was talking exactly brain. Brain. Beautiful. Okay, Miss Bilotic.
Yes.
What is the endocrine system?
Glands and hormones.
Yes. What do glands make?
Hormones.
Yes. What do hormones do?
They send messages.
Yes.
Chemical messages.
Who do they send chemical messages to?
Systems of the body, like the brain and the thyroid.
I'll take it. I'll take it. Cells, but you're absolutely right. Those cells are part of systems of the body. I will take it. Thank you. Where would I find some of my most powerful glands?
The brain.
Thank you. Awesome. Thank you, ma'am. Okay, everybody. Any questions before we move on to the digestive system?
I have a question.
Please, Ms. Pilatic.
Well, if someone has like a mental illness, like depression or anxiety, since it's in the brain, does it mess with their chemical messengers? Like, is there like an imbalance, or
Yeah.
is that what it is?
It could be. We know that the brain is not only very affected by chemicals and drugs, but it actually makes its own chemical and drugs. And we know that when those get out of balance, that it causes all sorts of problems. And it could cause all sorts of hormonal imbalances as well. And I mean, you've got hormones that make you feel nervous, even like your fight or flight hormones and such. So absolutely, it could affect your hormonal balances, and that could be part of the problem. And there's loads of research to suggest that a lot of mental problems or challenges or whatever have a chemical imbalance at their base. What we don't know is this. We don't know if the chemical balance was there to begin with, and that's what's causing the emotional problems, or if the emotional problems are causing the chemical imbalance, because we have research to support both. So I suspect both are true. And what I mean by that is you could be born, let's say, with an imbalance, or you could get a disease with an imbalance, and then you might be prone to all sorts of things. But we also know that certain types of thinking actually create more feel-good hormones or feel-bad hormones. It's honestly why we do the gratitude exercise. I mean, this is not woo-woo stuff. What now?
Like your mindset?
Yes, so your mindset will actually produce more feel-good hormones, and then you tend to see things in a more positive manner. So we know that you have control over your chemistry, and your chemistry has control over you. Both. And one of the things, like when you're struggling with something, you know, when you're depressed about it or worried about it, is trying to break that cycle and kind of get some positive thoughts going in there so you can change the brain chemistry so you can get back on track. And it's hard. I mean, we all know it's hard.
Longer.
I'm so sorry, what?
So we can live longer.
So we can live longer, but also so we can live better. We've all been sad or depressed before. It's not pleasant. It's just really hard. I don't think we want 150 years of that kind of thing, right? I'd rather 50 years of some really happiness, and it'd be great if you could have both, happiness and 150 years, whatever. But yeah, so good questions. And your thinking affects your chemistry, and yes, your chemistry affects your thinking and your hormones. Yes, yeah, for sure.
Thank you.
Thank you. Those are really good questions. And by the way, that means that massage can actually affect people's thinking in the positive. It really can be a very positive thing for them. Plus, it does this other really neat thing that massage does for people. And it's a great selling point when you're trying to sell your massage to people, which is, hey, you're worth it. Aren't you worth $80 and an hour every week? That's just for you, right? Receiving something that you don't have to return the favor, or gosh, my husband did this thing for me, it's so great, yeah, but now I need to cook dinner, or I need to thank. No, go pay somebody to take care of you, essentially, because we know that that sends a very positive signal to you that you're worthwhile, and you're worth it, and you're important. And that creates those feelings inside you, and that tends to make your life go more that way. Okay, let me start sharing here. Do we need a break before we start talking about the digestive system, like a 5-minute break to kind of clear the air? All right, I saw a nod, that's enough for me. 5-minute break, everybody, and we'll come. The digestive system. And thank you, Ms. Hanson, by the way, for doing a demonstration of the digestive system for us right now.
Yeah.
Okay. So, something to kind of remember forever. Forget about all the words we're going to learn and things like that. But it is 100% true that your digestive system is just a tube from your mouth to your butt. You really do eat stuff up here. It goes down a tube called your esophagus. That tube doesn't go into it doesn't go into a room. It just widens into this J-shaped thing called your stomach that then goes into this thing called your small intestine. That then turns into a bigger tube called your large intestine. Then goes down to your rectum and out of your body. It really is a tube that expands and it's different shapes and stuff like that, but it's all one tube. There are valves between this tube at certain places. This is your first valve. It's your sphincter valve. Right? This one I should close at 9 o'clock at night when I'm in front of the TV eating, but I don't. I open that one right up and put more food in it. And you've got a valve here to make sure your stomach acid doesn't come back up, but sometimes it does. You've got a valve here. You've got valves along the way. You've got two down here, thank goodness. But it is one long tube. Now, people that are into evolution, and I say that because I don't care either way, but people that are into evolution believe that this started a long time ago when cells and bacteria would be kind of shaped like a donut, and a little bit of food could go through the center of the donut, and they could sometimes absorb it. And then these bacteria and such started to figure out that if they were longer tubes, they'd have a longer time for food to go through them and nourishment, they could pick that up. And then in a way, you're just this big long tube with an outside to the donut and an inside to the donut. But your digestive system is one long tube. And this is the other thing. It works very mechanically. And here's what I mean. I think that we think like, oh, I ate some food and it magically kind of becomes part of my body. And there is a lot of neat chemistry involved, but it's not that magical. Essentially, I mean, it's amazing. I don't mean like that. But what I meant was it's very mechanical. Let me show you what I mean. First, what do? You break up the food with your teeth. You break it up into tiny bits, and you do that to increase its surface area, right? If you're trying to dissolve sugar in water, you don't want the sugar in big clumps. You want to break it up first. It'll dissolve better, right? And what we're trying to do is honestly just break up our food so it'll dissolve into our blood. Yeah. You can't... I should be. Some of you just asked if I was presenting. I'm not presenting. No, not yet. Gotcha. But I'm just breaking it up. Then I swallow it down. Then it goes in my stomach. There's more acid there, but the acid is doing what? It's breaking up the food. And then honestly, it's so broken up that by the time it goes into my small intestine, it's so small that it can absorb through the walls. And what's lining those walls? On the outside, on the inside, it's mucus, by the way, to protect me and help move the food through. But on the outside are little veins. And that food, the chemicals of that food, go into my veins and feed my body. And then my veins take them to all my cells. So in a real way, when you eat a steak or you eat a banana, in a real way, microscopic pieces of steak and banana that are no longer steak and banana, but they're still little pieces of steak and banana get into my blood. They're so thin they can pass through my small intestine and get into my bloodstream, and they can go around and find a happy cell somewhere that needs that thing, and the cell actually takes it and goes, I need a little piece of banana, thank you. Now it wasn't banana, it was a little piece of protein it needed or whatever at that point. But that's all it is you're mushing down food, breaking it up so small that it can absorb through your intestinal walls into your bloodstream so your blood can carry it all around your body with the circulatory system and feed your cells. Because remember, your cells are the most basic unit of life, and they're like little people, and they need steak and bananas too. Yeah? All right, I'm gonna start presenting now. But that's your entire circulatory system. If you want to kind of keep it kind of simple. And I always tell you this at the beginning of one of these lectures because I worry we get so caught up in the words that we forget what we're actually talking about. Yeah? Okay, so hopefully you can all see what I'm presenting now. Cool. All right. I love it. Yeah, so even here, your book describes digestive system as a disassembly line. It's a long line that takes stuff apart. Yeah, takes stuff apart. And you need this for energy to study and go to massage school and perform massage and all that kind of stuff. Your digestive system is composed of a whole lot of parts. Most of them are part of this tube. The oral cavity, a cavity is just an opening. This is my oral cavity. My pharynx is the connection of that oral cavity to my esophagus. My esophagus is my tube. It's my food tube that runs behind my windpipe, which is in front. Opens up into my stomach, which closes down into my small intestine. The small intestine, by the way, are small in diameter, but they're not that small. They're about 20 feet long. Opens up into my large intestine, which makes one final victory lap clockwise around my stomach, which is why when we were doing stomach massage, we were rubbing clockwise to move food through the large intestine. And then there are some other organs that help your digestive system, which is your liver, which is located over here. Largest organ of the body, by the way, liver. Gallbladder, which lives underneath the liver, and pancreas, which lives behind the stomach. So all down in this area. And they're important because they excrete certain enzymes and such that we're going to learn about that help to break down your food and make it more absorbable for you so you can get the fats and the proteins and the carbohydrates into your body so that you can take it around to your cells, and your cells need fats, carbohydrates, and proteins. All three of those are very good things that your cells need to make more cells and to help you be alive. Yeah? Well, what's the purpose of the digestive system? It's to give you energy and building material for life. Okay. So, some definitions that I think if you think about for a second, you won't have to write a lot of notes about. You're welcome to. I love it when you take notes, but I meant like, you might kind of already know these if you think about it. So ingestion is when I ingest. When I ingest something is when I take it into my body. In this case, into my mouth. That's ingestion. It's not digestion. I haven't broken it up. I haven't done anything with it. I've ingested it. You'll sometimes hear this where somebody's like, oh my gosh, I accidentally ingested that aerosol or whatever. But ingestion is just taking it into your body. Digestion is breaking it down into simple molecules. The act of digestion is what our digestive system does, where it breaks it down into simple molecules. And it does this with a lot of help of these things called enzymes. And enzymes, what do I want to tell you about enzymes? Enzymes are things that help chemical reactions happen easier. There's a lot of organic chemistry behind it that we're not going to get into at all, but enzymes help chemical reactions happen easier, usually with less energy. But anyway, so you've got lots of enzymes that help break up your food. But digestion is the breaking down of your food into tiny molecules. Absorption is when that food, here's what I talked about, gets absorbed through your intestines into your circulatory system, into your body. Yeah. And defecation is when you get rid of, eliminate, poop, the food that was indigestible, the stuff you didn't use. A lot of that is fiber, by the way. Fibrous material, which you find in a lot of fruits and vegetables. And a little side note about fiber. It's one of the largest missing nutrients in the American diet. So people go, well, fiber doesn't do anything for me. It's not a protein, it's not a carbohydrate, it's not, and that's true. You don't build anything with fiber. In fact, when you eat fiber, it goes all the way through your body and it leaves you. But your digestive system needs fiber. Fiber is what helps move food through you and keep you regular. And it's not just important to keep you regular, it makes your system work well. It works well off fiber. It's actually one of the big missing things from when you have lots of processed food, you don't get any fiber in your diet. Okay.
Question.
Yes, ma'am. Hit me.
Maybe I missed it, but you said fiber just goes through you, but does it still has nutrients that the cells absorb, right?
No, not the fiber, but the fiber comes with things like
Spinach and stuff.
yes. So when you eat,
Go ahead.
I'm sorry, when you go ahead and eat like a tomato or a carrot or whatever, those things are chock full of vitamins and minerals and carbohydrates and even some proteins. And they have fiber in them too. And so your body takes all the protein, all the vitamins, all the nutrients, all the carbohydrates out, and you're just left with the fiber at the end, and that's what you poop out.
Got it.
Yeah. And of course, we don't say poop, we say defecate. But you'll often hear me say things like your butt or your mouth or something like that, because I'm trying to still remind you like where this stuff really is. But defecate would be to go to the bathroom. Yeah. Anyway, yeah, so the fiber is intimately mixed in with those things. And the problem with highly processed food is they have lots of other nutrients in them, but usually no fiber. So it's a challenge for your digestive system, which is designed to have fiber running through it too. So when we look at this picture here, it's hard to tell that this is one continuous loop, but it is. Also, notice how big the liver is. Liver's on the right side of the body, is the largest organ. It sits up here right underneath the ribs. Right underneath the ribs here. And our liver, by the way, is a blood filter and things like that, but it also helps produce some things that help us with digestion, which we'll learn about here very soon, like bile.
Why is our stomach like all the way on the one side? I thought it was like the belly.
Yeah, it's not. So a lot of what you think of as your belly is your small intestines.
Oh.
Yeah. And they're what's getting full of food, and they're what's getting gassy, and there's what's, when you say I feel bloated, it's usually your small intestine, maybe your large intestine too, but it's your small intestine. And like I said, your small intestine's not so small, there's 20 feet of it. So stuff goes through the stomach, and then it slows down, starts going through the small intestine all over the place, and so that you can absorb food. Yeah.
Got it.
Yes. Yeah. And it takes us quite a while to absorb food, by the way. It usually takes us about a day for food to go all the way through us. Whereas a dog, like a 100% carnivore, takes about 4 hours for food to go through them. And there's a reason for that. They don't cook their food. Dogs don't cook their food, and they're wild animals essentially. And they're eating meat, which has lots of bacteria in it. And so their body digests it really fast and gets it out really fast, because the longer it's in there, the more the bacteria can affect them. We cook our food. We're designed to actually eat lots of plants too, and so our food takes longer to go through us, so we have longer absorption time. Makes us more efficient too.
And doesn't the liver have over 900 jobs?
I have no idea, but that would not surprise me, what you just said there.
I think in high school my human AP
Yeah.
told me that.
Well, I would suspect they're right then. I'd suspect they're right because nothing in your body, by the way, just has one job. It always has a lot. And the liver produces all sorts of chemicals and does all sorts of things. And also, your AP teacher probably knows a whole lot more about anatomy than I do, in the sense that I know a lot about muscular anatomy, but when it comes to general anatomy, it's not my, So I would say 900 sounds a little high, but yes, I would think it does a lot of things. Yeah, and 900 could be dead on right. It depends on how you count those things, right? Be a good thing to Google.
explains why food poisoning can show up so late.
Yes, because it takes a while for it to get into you and absorb and all that kind of stuff. Is that what you mean, Ms. Petrie?
Yes.
Yeah,
Right, dogs never really get stomach sick that often.
they don't. Yeah,
What they do is because they eat something that they're not supposed to eat, but
Yeah.
most likely that's really not that many items if you think about it.
no, they're pretty
So it makes
protected.
sense that it kind of just goes through them so quickly.
Mhm.
I give my dogs carrots as treats, and let me tell you, they're like pooping machines.
They are. Well, Mother Nature made them that way to protect them because the carrots are fine, but if they eat like roadkill, right, which is fine, they're supposed to, but the fact is it's loaded with bacteria. If any of us ate that, we would die. But dogs gets it through their system so quickly that the bacteria doesn't have time to take hold. That's part of the purpose. And you're absolutely right. Carrots go through them very quickly. Yes.
Okay, so to follow up, it said that the liver has over 300 behind the scenes functions.
Ooh, I like that. Okay. Still a high number.
Mm-hmm.
Yeah. Cool. Yeah, I would definitely think that. I mean, right now there's about 1 million processes going on in your body right now that have to work perfectly just for you guys to be sitting here. So I'm sure the liver is doing 300 things behind the scenes. All right. So the gastrointestinal tract is essentially your digestive system, and it is this tube. This is the gastrointestinal tract. This tube, from start to finish here, is the gastrointestinal tract, or GI tract. GI, gastrointestinal tract. It is a muscular tube from your mouth to your anus. Miss Monreal, what kind of muscle is around this muscular tube from your mouth to your anus, the GI tract?
Smooth muscle?
Absolutely. So this is where the muscular system is combined with the digestive system. It is smooth muscle around this entire thing. And we're going to find out for a very, very good reason. The smooth muscle around this entire thing squeezes in this repetitive motion called peristalsis. And peristalsis does a couple things. It literally, if you have a tube like this, it literally squeezes your food down to the next spot and squeezes. It's squeezing down a tube to squeeze your food down. It's why astronauts can drink in outer space. They're not using gravity, they're actually squeezing the food down. And then when it gets to your stomach, right? Have you guys ever felt your stomach moving? The muscle around it, the smooth muscle around it, it's literally doing this. What's it doing? It's grinding up your food even more. So first you started by grinding up your food with your teeth. Then it went down your throat, and your throat squeezed it down with peristalsis, this rhythm-like squeezing. Then it got your stomach, and it squeezed and squeezed and squeezed and squeezed and squeezed and mixed it with acid and all this kind of stuff. And then it went into your small intestine. Your small intestine squeezes it along. And then it gets to your large intestine, and it squeezes it along. And then later when you have to go to the bathroom, you squeeze it out of your body. And that's peristalsis. That is that action of repetitive squeezing, like this part squeezes, then this part squeezes, then this part squeezes, this part squeezes, and it works food along. It's this rhythmic kind of squeezing, peristalsis. This whole system here is lined with mucus. It's lined with mucus for a lot of reasons. In your stomach, it's lined with mucus so that your stomach acid doesn't burn a hole through the side of your stomach, because your stomach acid is that strong. It could actually burn a hole through your stomach, but the mucus is very good at stopping it from doing that. And so the cells in your stomach actually make mucus to protect themselves. You also make mucus in your throat and stuff to help food slide down, but to also catch other types of bacteria in there. And you make mucus in your small intestine, large intestine to help the food move along. It acts as a lubricant.
Hey, quick question.
Yes, sir.
Since we're talking about mucus in the digestive system,
Yeah.
this is more of a personal question, but I assume I'm not the only person who experiences this. Whenever I eat late, I notice that, the next morning, I wake up with a lot of phlegm and hacking on mucus. But if I stop eating past 8, then I'm fine. But yeah, if I end up eating sometimes I'm up late, I'll eat at 1, get hungry, whatever. Then yeah, it'll be sometimes pretty bad in the morning. I'll be all it's gross. But do you know why?
Yeah, it's your digestive. By the way, you're right. You're not the only one who experiences that. It's your digestive system. When it doesn't just make mucus all the time, it makes more when you eat. And so it turns on your mucus making system more when you eat, and that's why and then you go to bed and you've got extra mucus in the morning.
Okay.
Yeah.
So just try to stop eating late?
Yeah. Yeah. Yeah, there's nothing wrong with it. It's actually your system working well, but you're right. It's making lots of mucus, but you're not walking around, so you lay down and it kind of all sits there and gets up in your nose and stuff, everything.
Okay.
Yeah. This slide is very confusing, and I'm going to try to make it as simple as possible. All this tubing here isn't just floating around inside your body, because if it was, it would be all down in your ankles. It's held to your back and to your front and to your sides by this fascia called your peritoneum. And it's this membrane that helps stick this stuff in your body. So it can jiggle still, but it keeps my small intestines where they're supposed to be. Right? That's why you can run and things like that. You've got this thing called peritoneum. Now, they give the peritoneum lots of different names. So if it's behind your organs, kind of in your back, it's called mesentery. That's peritoneum still. If it's in front, it's called omentum peritoneum. It's got all sorts of names, but it's peritoneum, and all I really care is that you realize that there's fascia attaching your organs to the sides of your body so that they kind of stay there. And they've got some shock absorption too, by the way, because that fascia holds them like the spider web and lets them jiggle, but not break loose, right? And that's peritoneum. It's just fascia that holds your organs where they're supposed to be. That's it. I don't think you need to know the 35 names for it, depending on where it lies. Cool?
So,
yeah.
is it just remember last week when I asked about the hernia?
Yeah.
That's what you were talking about?
Yeah.
So it's pretty much kind of like a sausage casing in a sense, where it's just holding all the little inside parts together?
Sure. Yeah.
Okay.
Yeah. And kind of like your spider web thing too, depending on where it's at. But yes, it is connective tissue that's holding all this stuff together.
Cool.
And helping glue it to your body. So it needs to wiggle around. It's very important. When we all did abdominal massage, we were able to move stuff around. But it's still hooked to my back and my front and my side so that my small intestine still stays in roughly the same spot. It needs to. Yeah. And by the way, my heart and my lungs. I mean, everything has this peritoneum. This fascia inside you kind of holding your organs in place. Yeah. And sausage casing is a very good example. You're right. It is a membrane that would look a lot like sausage casing. Yes. This is a good example, a good picture of kind of where it runs, but it's really everywhere, everybody. Okay. So, after we eat this stuff, we chew it or we masticate it. Masticating just means chewing. You're all a bunch of masticators. Chew, 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 right? In fact, we use a very large muscle here to chew. Anybody know what this muscle is called right here? Anybody?
Is it your masseter?
Yeah, it's your masseter. Your masseter helps you masticate. That's why it's called your masseter. And you can feel this muscle. It's the big muscle that's in your cheeks here. And it helps you masticate, which is break food up. And then that gets it down to, you get saliva all around it, and it gets it down into like a ball, roughly a ball, and that's called a bolus. And the bolus is the thing that's going to kind of move through your body. Yeah, kind of comes down your throat as a bolus. It's just, I mean, it really is just a lump of food with saliva around it all broken up, but they like to give it a fancy name, so it's bolus. Yeah. And your saliva has kind of two really big purposes. One is to lubricate this bolus so it'll go down your throat. And two is it's got digestive enzymes in it. Remember, enzymes are these enzymes are these things that help chemical reactions happen better. So enzymes help the food to start breaking down. It's why they tell you chewing's so important, is because it makes less work for your stomach then. So you break the food up, you surround it with saliva, there's all these enzymes in saliva, and that helps to start to break down your food. And you've got some very well-known enzymes in your saliva, like amylase and lipase. And amylase helps with carbohydrate digestion, and lipase helps with fat digestion. Remember, lipids are fat. Lipids are fat, and lipase helps with fat digestion. It's an enzyme that helps with fat digestion, and amylase helps with carbohydrate digestion. I mean, you will need to know that a little bit, but to be very honest with you, as a massage therapist, you don't need to know much more than the fact is that your saliva produces enzymes that help break up food, and that helps lubricate it before you swallow. It's really, really it. And this is a picture of peristalsis, a picture of the contraction that's moving the bolus along. A picture of peristalsis. You better see a film of peristalsis because it looks cool. It goes, it's like a ripple down the tube with a smooth muscle. It's kind of cool. Okay, so this stuff is important. It's really important you know where certain things are in your body. You're a massage therapist, right? So we care about locations. We're very physical anatomy people. The chemical stuff may not be as important to us, but I need to know where your liver is. Like, I need to know where your throat is, things like this, right? So just to be really clear, the esophagus is a tube. It's my food tube, but it's behind my windpipe, which is called my trachea. I am pushing on my windpipe here. Behind it is my esophagus, my food pipe. Just so you know where they are. Yeah. So when it comes down through my esophagus, there's a big muscle. When my esophagus comes down, there's a big muscle that helps me breathe that it has to get through. Anybody know what that big muscle is inside my chest that helps me breathe? It's my main breathing muscle. It's inside my rib cage. When we were moving each other's rib cages around the other day, I said, you can actually help.
Is that your diaphragm?
Your diaphragm. Giant mushroom.
No.
Oh, hello. We can hear you now. Ms. Torres?
No, I said lungs.
Well, the diaphragm is what moves your lungs. So good. The diaphragm is this big mushroom-shaped muscle. We're going to learn about it later. And when it contracts, it goes down like this, and it pulls your lungs down. It helps you breathe. But the fact is, it looks like a big umbrella in your rib cage, and the esophagus has to get through it. And there's actually something called the esophageal hiatus. You ever heard somebody say I'm going on hiatus? Anybody ever heard the term hiatus? It means I'm going on a break. The esophageal hiatus really is a break in the diaphragm that lets the esophagus get through. And that's called this esophageal hiatus. It's a hole in the diaphragm. You've got hiatuses all over your body, by the way, because you do have all these sacs that are protecting stuff, and you have to have holes through them for veins and arteries and things like that to get through. And where your esophagus goes through, your diaphragm, there's a hole there, and that's called the esophageal hiatus. And hiatus is a good word to know. We're going to learn about other hiatuses. Goes through that, goes into the stomach, which is a big J-shaped kind of opening in the tube. There are folds in your stomach, and they're called rugae. R-U-G-A-E, rugae. You would think rugae, but I've always heard it pronounced rugae. These folds are so your stomach can expand. So Ms. Hunter, in that sense, you're right. You know, like your stomach does expand, but usually we're feeling it more down our intestines later. But our stomachs do expand. If you've ever seen like the hot dog eating contest where the guy eats 40 hot dogs, it's always some little guy too, I don't understand it. But anyway, his rugae are unfolding and that stomach's getting really big. In fact, he's had to train his stomach to stretch. And then when food gets in your stomach and it's all getting crunched around in there and stuff like that, and it's getting mixed up with stomach acid and things like this, it now becomes this kind of liquidy stuff, and they call that chyme. Chyme is now the bolus has come down into the stomach and it's been broken up and it's been mixed with stomach acid and it's all soupy and whatever, and it's called chyme. It's all mixed with gastric juices and all that kind of stuff. And that's chyme. So here's a picture of the esophagus coming down into the stomach. The ripples that are the rugae that allow the stomach to expand. And then it's going to go through a sphincter. Now what is a sphincter, everybody?
A round muscle type of hole?
Yes. So the most obvious one is in my mouth here, sphincter. You have another one in your bottom that's very similar, sphincter, but you've got a whole bunch in your digestive tract to control food moving through. And this one, as the stomach empties food out into the small intestine, it goes through what's called the pyloric sphincter. It's the name of the sphincter that opens up to let the chyme into the small intestine. It goes through the pyloric sphincter. Yay! And now it's in the small intestine. And that's important because the small intestine is where most of your digestion actually takes place. By that I meant most of your absorption actually takes place in the small intestine. Important little fact about the stomach is it actually produces hydrochloric acid, which helps break up your food. It also does, and hydrochloric acid is really strong acid. It also does something else that's kind of neat, hydrochloric acid does. It not only breaks up food, but this kind of goes to what you were talking about, Ms. Petrie. It helps kill bacteria. So when we eat stuff, some bacteria does get into your body all the time. And one of the nice things that hydrochloric acid does is it does a pretty good job of destroying bacteria. It's one of the things that really protects us. So now this food has been chewed up, it's been coated in saliva, it's been swallowed, peristalsis has moved it down into our stomach, it's been mixed with hydrochloric acid, other enzymes, and all sorts of stuff. It's killed off bacteria, it's broken the food up, and eventually it's going to go through the pyloric sphincter to get to the small intestine. And then I said in the small intestine is where most, 90% of your nutrient absorption happens. So the idea is now the food is this liquidy kind of stuff, watery, by the way, very liquidy kind of stuff. And now it's going to move through the small intestine and actually be absorbed through the walls of the small intestine and picked up by the bloodstream. So that food can get to your cells. Please, ask the question.
For the last slide, I don't know if I missed this or not, but you only went over hydrochloric acid. Did we care about pepsin or whatever, or,
Not really.
or did you already do that?
No, I didn't, and I skipped it on purpose.
Oh, okay, cool.
Yeah.
I just want to make sure I was not missing something. Okay.
Yeah, again, no, Miss Hunter, you're dead on. And I think you guys all noticed, I skip over certain things because I don't think we're going to retain it, and there's only so much time in the class, and so I'm like, what do we want to spend time on? I want you to know your stomach produces hydrochloric acid because that's when people have acid reflux, or you get heartburn, that's hydrochloric acid coming back up. But pepsin doesn't play in big to being a massage therapist, so I don't mention it. But no, you didn't miss anything.
Actually,
You're on point.
Generally, thank you. Generally, I just look at you and I don't look at the slides. So today I'm looking at the slides, and that's why I noticed.
Ah, cool. All right.
Yeah.
Yeah. Okay. So, by the way, your small intestine is strangely enough your longer intestine. So you've got a small intestine and a large intestine. The small intestine is longer. It's not bigger around. It's called the small intestine because the tubing is smaller here, but it's like 20 feet long. The large intestine that it's going to head to is bigger around, but it only goes up one side of my body, over the other, down the other, and out. That's it. So it's, I don't know, it's 3 feet long. This thing's 20 feet long. So it came out of the stomach, this chime, through the pyloric sphincter into the small intestine, and eventually it's going to leave the small intestine through another sphincter called the ileocecal sphincter or ileocecal valve, but it's a sphincter, into the large intestine. Yeah. While still in the small intestine, they've divided the small intestine up into different sections. And these are fairly commonly known, that's why I'm telling you them. These are sections, the first one is called the duodenum. And the duodenum is important, it's the first section of the small intestine. It's important because it contains little ducts, little tubes, that the liver and the gallbladder and the pancreas use to drop their enzymes into the small intestine. So we haven't learned about this yet, but we're about to. The liver, the gallbladder, and the pancreas make all sorts of enzymes that help you digest your food, and they kind of inject them into the small intestine in the first section of the small intestine, and this first section is called the duodenum, and that stuff helps you digest your food. So the duodenum is famous, well known, because that's where the liver, pancreas, and gallbladder enzymes get in and start helping to further break down your food so that you can digest it. Yeah. Cool. And then it keeps going through, goes through the next section, which is called the jejunum. And then the last section, which is called the ileum. I'm sorry, the reason I have a hard time saying it is I always want to say ileum, which is your bone, this crest, your ileum on your hip. But it's ileum, which is the last section. What's interesting about the last section is it has these things that are called Peyer patches, and those are full of lymphatic tissue, and we have not talked about this yet. But let's just say they're fields of white blood cells. White blood cells that are meant to kind of clean up any foreign invaders that are in there. Make sure that you deal with those. So you've got, we'll learn about your lymphatic system later, but it does two things. It helps you digest fat, which it's doing in your small intestine, and it also is part of your defense mechanism. It has lots of white blood cells in it. So a lot of your fat digestion happens in this area too. Fat, by the way, is very hard to get into your bloodstream because it's too big, and so you have another system in your body called your lymphatic system that picks it up from the intestine, and it does this from these Peyer patches as well. Sorry, that's not a great explanation, but we haven't done the lymphatic system yet. So you have blood vessels that go to your small intestine. You've also got these things called lymphatic vessels that go to your small intestine. And these Peyer's patches is where a lot of your fat absorption goes into your lymphatic system. Your lymphatic system goes to all your cells too. So that's how you get a lot of fat to your cells. And fat's important, by the way. It carries a lot of vitamins. A lot of vitamins are fat soluble. So it's not a bad thing at all. How does your intestines absorb food? Anybody know how a radiator on a car works?
I'm assuming it works like your intestines do.
Yes, Ms. Morel, you're absolutely right. The more surface area you have, the more absorption you can have. So if I have a piece of paper towel and I want it to absorb water, would 2 pieces of paper towel absorb twice as much water as 1 piece of paper towel? If I have to take a whole bunch of paper towel and fit it into a small area, instead of laying it down flat, can you see that if I scrunch it up, this is a lot more paper towel than this is? Can we see that? So your intestines do this too. It's very clever. By the way, your body does this in a lot of areas. When we learn about the lungs, they do the same thing, kind of. It's got these little finger-like projections that are called villi. And what they do is increase the surface area. There's a reason it takes me longer to do that than it does to do this. It's because there's more surface area here. This is, if I stretched this out, back out, it would all of a sudden be that long. Can we see that? And those are called villi. They're finger-like projections meant to increase the surface area in your intestines so the food has more places that it can absorb into the bloodstream. Then you've got little blood vessels that are in here and stuff. But it's increasing surface area. This has a lot more surface area than just this. Right? If I took this line and scrunched it up, it'd probably just be this. So I've increased the surface area. What can I do to make the villi help it increase the surface area even more? Now, why is this taking me so long to draw? Because of all the surface area. So on top of the villi, you can have what's called microvilli, which are finger-like projections on the finger-like projections. And that gives you even more surface area for food to absorb. And that's what your body does. And actually the small intestines, if you looked at them when they're alive, and were clean, and they are clean quite often, by the way, they're not always carrying like poop through them, sometimes they just clean out. They look and feel like velvet because of all the microvilli. Because it's like hair-like projections with hair-like projections on them, all meant to absorb food. So if you want to absorb food, and let's say you have this kind of weird straw that some stuff would leak through, well, if you took that straw and you gave it all sorts of like little increased little surface areas, that's a lot more room for stuff to leak through. And that's the whole idea. You break the stuff down really, really small, and then you want it to leak through this filter. But if you ripple the filter and then ripple the ripples, you've got a lot more filter for it to leak through. You've increased surface area.
So, if somebody has like leaky gut, is that going to be in the small intestines?
I don't know. There's a lot of literature out there on leaky gut, and I don't know what to think about it right now. I don't feel qualified to answer about it, but I guess I question it because your gut is supposed to leak. Now, obviously, when they mean leaky gut, they mean your gut is leaking in ways that it's not supposed to leak, right?
Correct.
But in a way, like, I want my gut to leak out into my capillaries.
Yeah, when you said that, that's why I was like, wait, so it's supposed to leak?
Yeah.
Okay.
Well, I want the right kind of food, these little molecules here. Like, if this was my intestine, here, let me draw this again. I'm not going to draw the whole thing, it'll take forever. But let's suppose that we have these villi in this tube here. So this is the tube. Food's coming down the tube here. Coming to this tube, I've got these little capillaries everywhere. I'm hoping that food leaks out into the capillaries and goes up in the body. Now, I admit that there's stuff in the intestines you don't want going out in the body, and that could be very legitimately leaky gut. But I don't know how to feel about that. I don't know enough about the whole thing. And so I definitely don't know, by the way, if it happens in the small intestine or large intestine more. But definitely 100% I do know that your gut is supposed to leak at least into your capillaries, which turn into your veins, which go into your circulatory system, which get carried out throughout your whole body and dropped off at every cell of your body. Otherwise, your cells would die. That literally, you are eating for your cells. And so we definitely want the right type of leaking, you know? And it's possible that leaky gut, if it exists the way that people are saying it does, is the mucous membrane is getting kind of torn down in those areas, and that the wrong kind of stuff is getting through. That's possible. Yeah. And what's happening here is not only do you have a lot of enzymes in here, you've got bacteria in here. Little bugs, little microscopic bugs. And that's what they mean when they talk about gut health, is do you have the right bacteria in your gut? Because those bugs actually eat up your food and they poop it out, so to speak. They don't really poop, but they excrete it. And the stuff they excrete is actually easier for you to digest, and that helps it get in the capillaries too. So you all have bacteria in your gut that you're supposed to have in your gut.
Well, I did learn this from Magic School Bus, Miss Frizzle.
I love her.
If you don't go poop when you feel like it, that it's just sucking more water out of that poop, and that's why when you hold your poop, it's harder, and people get more constipated. So everybody, you shouldn't hold your poop. Go when you feel like it.
Yeah, so you're jumping a little bit ahead, but since you brought up, let's talk about it really fast, because you're absolutely right. So after it goes through the small intestine, right? It goes to the large intestine, and the large intestine essentially goes up, over, down, and out. Right here, through your anus. And the main job of the large intestine, we're about to get to this anyway, but the main job of the large intestine is to extract water back out of your food. Because water is a precious resource. We don't think of it as a precious resource because we all live in the city, right? I can literally walk down the hallway. It's the one thing I can still get free almost everywhere, right? Walk in the hallway right now and I can have a drink of water. But if you lived out in the wild, water conservation is a big deal. And so when I eat food, I use all this water to process it. My body's like, great, the small intestine's got all the good stuff out of it. But my body's like, we're not just dropping this off with a whole lot of water in it. We want to get the water back out. And so the large intestine is meant to reabsorb the water that's left in your food. And depending on how hydrated you are, tells your body how much water to take out of it. You're absolutely right. So holding your poop causes that to take out more water, but also being dehydrated. Because if my body says, hey, I'm lacking H2O, it's going to try to take more out of my intestines. If I'm really well hydrated, it doesn't try to take as much out. So in general, I'm not trying to get gross with anybody, but in general, your poops are harder when you're dehydrated, and they're runnier when you are hydrated. I realize there are exceptions to those rules, like food poisoning, things like that, but in general, when they're runny, it's because you get a lot of water in your diet and fiber. And when they're hard, it's because you're not getting a lot of water and fiber in your diet, so your body's trying to take it out of your intestines.
So whatever the mixture is it chyme when it's going through the small intestines? That's what it's called? Or was that in the stomach?
No, it's chyme when it's going through the small intestine.
Okay.
Yeah.
But then when it goes in the large intestine, that's pretty much poop.
Yeah, it really is.
Okay.
It's ready. The large intestine is, you've pretty much gotten all the nutrients out of it you're going to get. Your body's going to take whatever water it needs. If it doesn't need any, it's not going to take a lot. And then yes. And mostly what you're going to dump at that point is fiber. But yes. Yeah, and you're right. It's kind of poop by the time it got to the large intestine. You're right. It's kind of done with the other stuff. The large intestine is a victory lap to get rid of extra water. Yeah. Cool. Here's a good picture of the villi and the microvilli. Well, at least the villi. And it shows you how that increases the surface area on the small intestine for picking up food. And you can see, by the way, the vein and artery, the capillaries inside here that are meant to pick up the food. Yeah. Okay, moving right along. Might have already talked about this, but lactase and lipase are enzymes that are found inside your small intestine. What did she say? I can only imagine. Yes, it would be a great drinking game. Yes, we would all be drunk. By the way, speaking of being drunk and relating it back to this discussion, one of the things that makes you feel hungover is dehydration, for one thing, to make you feel hungover. But also, the alcohol kind of messes with your biome, your healthy bacteria in your intestines. So they don't really enjoy swimming in alcohol. It's not really food for them. And so it kind of messes with them, which is why sometimes one of the best things you can do for a hangover is eat a meal and get it to go through your body, because it's letting your bacteria build back up again and rebuild that biome.
So water and alcohol are absorbed in the stomach, correct?
Well, yes, they are, but alcohol still gets into your small intestine and such, yes.
Okay.
And it affects the bacteria in there.
Okay.
Yeah. And by the way, water is kind of absorbed everywhere. I'd say it's more absorbed, like we said, in the large intestine. Okay, so small intestine goes through the ileocecal sphincter. Wow, it would be a good drinking game, Miss Petrie. Ileocecal sphincter, which is just another gate, another sphincter valve, into the large intestine. We already said this. Its main job is to absorb water. They say electrolytes too. Electrolytes are things like potassium and sodium and calcium ions. And electrolytes are important because they help your nervous system work and your muscles work. But they're kind of like water and salts, essentially. You have 3 parts to your colon. One that goes up, ascending. One going across. What plane goes across your body?
Transverse.
Yes, and this is called the transverse colon. Yeah. Then a descending, and then a sigmoid. The sigmoid colon is the last little bit of your colon, of your large intestine. And this is what makes you feel like you have to go to the bathroom. When there's a sphincter valve kind of like here and here, and when this fills up with poop, with fecal matter, it's what gives you a feeling of like, oh, excuse me, bathroom break. That's when and you have choice to hold that for a while, as you said, but eventually you need to go to the bathroom. It's a very good idea too. Anyway, but that's when your body gives you Your nervous system, by the way, literally tells you, it sends a signal and says, we're feeling pressure down here. By the way, that's not all it tells you. Not to get too detailed, but it's kind of fascinating. You have nerves down here that tell you about pressure, right? That tells you if you have to poop. Guess what else they tell you though? They tell you if they feel wetness down here or air down here. That's your nervous system too. That's how you can fart without pooping yourself. Your body can actually tell you, hey, I know you feel full down here, but it's not poop, it's gas. That's your nervous system telling you that. It actually picks that up. And you're like, oh, I don't really have to go to the bathroom, I just need some privacy so that my classmates don't make fun of me. And you go fart. And when you fart, are you farting? Not really. Your bacteria is. It was your bacteria up in the small intestine, even the large intestine, but the small intestine that was eating your food, and it's farting out methane gas. That's one of its waste products. And then you eat its poop, really, because it's all digested for you, and you are releasing its methane gas. You guys don't make methane gas. You can't make methane gas. Your bacteria makes methane gas. So you can be like, oh, excuse my bacteria, because that's not really you. You're literally just releasing the pressure from that biome. It's the bacteria that's farting. Yes, Ms. Monreal.
As far as abdominal massage, I know we went over it a little bit. Okay, so now looking at the large intestine. So if somebody was, yes, constipated, you would move that right along, clockwise, right?
Yep.
What about the small intestines, which I'm assuming they're going to be doubled in the middle? Would that, like, is there a benefit to that also?
Yes, but you have to massage them in this order. Watch, really careful. This is small intestine. Don't forget that, okay? Did you get that? They really are, they're all wound up in there. You can't, like you could push on them, kind of move them around a little bit, but they literally do like...
But there's not necessarily like a benefit, is there? I mean, to stimulate anything, what would the benefit of that be?
I think you are stimulating blood flow to there. I'm not trying to move food along through the small intestine, really. It should be moving along on its own. I think the benefit to all this stuff is you increase blood flow and that this stuff doesn't ever get moved around. And when you push the small intestines around, you give a chance for that tubing to kind of resituate, make sure it's not crimped up anywhere and all that kind of stuff. So I think there is benefit in that sense.
Okay.
Yeah. And even though I said go clockwise, go clockwise, go clockwise, I'm rarely massaging somebody to try to control their regularity. I'm just trying to kind of keep good gut health, which I think is controlled by just moving everything and kind of moving it around and getting blood flow there and all that kind of stuff. Okay. Boom. We don't need to know about that. Here's a neat picture of your appendix. Your appendix is at the beginning of your large intestine, and I don't know if this is covered in the slideshow, but the appendix is very interesting. We have for the longest time not been sure what the appendix does, and now they've got some pretty good guesses. Have you ever had the flu so bad that it's coming out both ends? All right. You have dumped out your intestines, you've dumped out your stomach, all that stuff. Well, when that happens, you've dumped out a lot of your good bacteria, right? And sometimes when they give you antibiotics too and things like that, I'm not saying you shouldn't take them, but they are really good at killing off your good bacteria too. Well, we think the appendix, this little dangly little sac down there, might be a warehouse for your good bacteria. Because there's not a lot of flow through there, and so it doesn't matter what kind of, it's coming out both ends. That little area never empties out. And we think it might be a warehouse for good bacteria. So that your intestines can repopulate with good bacteria. That's the appendix. We don't know for sure. But I love that.
So what happens when, you know how they say your appendix burst or like something like that?
Yeah.
But they have to get it out or
They do. They have to get it out. They have to get it out and seal up that area. And this is where, this is leaky gut syndrome, Miss Monreal. If your appendix bursts, you now have poop leaking into your body with bacteria. That bacteria is fine inside your intestines. It helps you do all sorts of stuff. You don't want it running around wild. Like that bacteria is having a party that needs to stay in your intestines. You don't want them partying throughout your whole body. And so that's why it's so dangerous. It can actually infect your whole body. So like many things in the world, they're good in one place but not good in another. And that bacteria is great inside your intestines. It helps to digest your food. You don't want it just going everywhere around your body. So yeah, when your appendix bursts...
Do you know why they happen?
I don't. I mean, I do know why it happens sometimes in older adults sometimes. It can be due to excessive drinking, for one thing, because it inflames some people's appendixes and they can burst from that. I don't know why it happens in younger people. I don't know. Okay, you've got some accessory organs that help your digestive system. These are not part of the tube. It's your liver, gallbladder, and pancreas. Yeah? Liver, gallbladder, and pancreas. Again, liver is the largest internal organ in the body. The largest organ in the body is probably your skin, but this is the largest internal organ in your body. It's huge. It's on your right side. It's up underneath your rib cage. It's right about here. It's like both my hands here. Boom. Underneath it is the gallbladder, and one of the job of the gallbladder is to actually store some of the stuff the liver makes, believe it or not. And then you've got a pancreas, which is behind the stomach. All three of these, the liver, pancreas, and gallbladder, are important because they create enzymes that help you break down your food. And if you look at this slide, you see the duodenum, which is the first part of the small intestine, and it's right next to the gallbladder, the liver, and the pancreas, because those things dump that stuff into your small intestine to help it digest, help you digest food. And they do that through this duct work that's in there, which is just tubes in there. The main thing that you should know your liver does, we're not going to learn the 300 things. We're only going to learn one of them. The other 299 is in another class. But it creates bile. It creates bile, which is the green stuff. If we go to a cadaver lab ever, you can actually see it in dead people too. It's green, powerful fat digesting stuff. And your liver creates bile. Your liver creates bile and then sends it to your gallbladder, and do they have that in there? They should. It sends it to your gallbladder, and your gallbladder actually stores and concentrates bile. It doesn't make it, it actually stores and concentrates it. By the way, being able to absorb fats means you can absorb fat-soluble vitamins like A, D, E, and K. You don't need to know what the fat-soluble vitamins are, but you should know that some really important vitamins in your body are fat-soluble, and if you can't break down fat, you can't get to the vitamins. And bile helps you do that. So the liver produces bile. Bile helps you break down fat, helps you absorb fat-soluble vitamins, and it's stored in the gallbladder. And the gallbladder is just underneath the liver. And then there's the pancreas, which is located behind the stomach. It also produces enzymes that are good for digestion. All sorts of types of digestion, by the way. I'm not really going to get into all these. But it does help with protein digestion and carbohydrate digestion and fat digestion. By the way, do we all know what carbohydrates are? Because they get a bad kind of rap in our society, but most of your enzymes in your digestive system are designed for for carbohydrate digestion. You're designed to operate primarily off carbohydrates. Carbohydrates are sugars. Basically like table sugar. So why is sugar bad for you and carbohydrates could be good for you? Because most carbohydrates are complex carbohydrates, which means it's a sugar plus 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 a sugar. When you eat table sugar, you instantly get sugar in your bloodstream. It's too much too fast. And when you have extra sugar, it has to turn to fat, you have to deal with it. When you eat a complex carbohydrate, this is not sugar to your body yet. It has to come along here with some scissors. It has to snip this sugar off. It has to snip this sugar off. Those scissors are called enzymes. Snip this sugar off, snip this sugar. It takes it a long time, and what it does is it's eating like little bits of sugar. And little bits of sugar are how you operate. That's what you make ATP out of. That's your energy. So getting very small, tiny, regular doses of sugar are great. And you get those from fruits and vegetables. They're loaded with fiber, but they're also loaded with carbohydrates, but they're complex carbohydrates. The sugars are all bound up and your body has to break them apart slowly. So carbohydrates are sugars, but they're complex sugars. They have to be broken apart. Boom. Okay, we are at the end of today's presentation. We of course have work for you guys to do because I'm lazy. No, I actually think it's a good exercise, I really do. So please listen up. I hope everybody's here and listening. Miss Bilotic, you're doing cirrhosis. We of course want to know very simply what it is and if it has any relation to massage. Can massage help it, hurt it, anything we need to know about that? Miss Cooper, you're doing constipation. Miss Felix Osuna, Crohn's disease. Miss Hanson, diarrhea. I think there's a song and everything that goes with that, so I'm expecting something pretty enlightening. Again, I want to know if massage has anything to do with these things. It may not, by the way, at all, so don't rack your brains, but we want to know, really understand what it is and all that kind of stuff. Miss Harper, gallstones. Miss Hunter, because I love you, I gave you the one with the longest name possible. Gastroesophageal reflux disease.
Gastroesophageal reflux disease.
Yeah, nailed it. Cool. Mr. Kandaris, irritable bowel syndrome. You're going to have a lot of clients tell you they have irritable bowel syndrome or IBS. I'd love to know what the heck that is, Mr. Kandaris. Miss Monreal, peptic ulcer disease. Yeah?
Yeah.
Thank you. Miss Nguyen, ulcerative colitis. Are you there, Miss Nguyen?
I get that.
Okay, ulcerative colitis. Can you say colitis?
Colitis.
Yeah. Okay, ulcerative colitis. And Miss Petrie, viral hepatitis. Yeah. I still think there's 3 of you left. Miss Stanley, Miss Torres, Miss Yanez, I realize we already went over these things, but I want people to review. I want to make sure this class does not graduate with not knowing where the liver is, the gallbladder, the small intestine, the large intestine. So can you just please, Miss Stanley, can you just please review the basic functions and locations of the liver and gallbladder? If there's anything related to massage we should know about, there may not be. Miss Torres, the small intestine, where is it located? Basically, what does it do again? This should be review. We already covered it today. I'm not looking for new stuff, although if you find it, that'd be great. And Miss Yanez, just go back over the large intestine with us. Again, good. What I'm trying to do is review here for people. Repetition, repetition, repetition. Cool. And we should all know where the liver is in the small intestine, large intestine, things like that. Cool. Yes. Yes, it does. Okay. Cool, cool, cool. Any questions? I'm going to stop sharing that. Any questions?